Okay, I'd like for you to try exercise 45 on page 309. So what I'd like for you to do is turn the video off, read the problem, and see if you could figure it out, and then turn the video back on and we'll check back in to make sure you got it correct. Okay, so the first question is, what is the probability of type AB blood? And you know that all the probabilities must add to 1. So you'll say why, because all probabilities sum to 1. If it is a legitimate probability model. So A is going to be the probability of AB blood is going to be 1 minus the probability of O or A or B, which is going to be 1 minus, and in parentheses you're going to do 0.49 plus 0.27 plus 0.20 is going to be 1 minus 0.96, which is 0.04. B says, what is the probability that the person chosen does not have type AB blood? So I'll say probability, and I'm going to say not AB. That's just a symbol that represents not. And in a minute I'll show you how to write it a different way. Is just going to be the other percentages or probabilities that make up the total of 1. So 0.96. And then C says Maria has type B. She can safely receive blood transfusions from people with blood types O and B. So O and B, so these two. So what is the probability that a randomly chosen Black American can donate blood to Maria? So it's going to be the probability basically of O or B is going to be the probability of O plus the probability of B. And I'm going to go ahead and mention this here. These two events are mutually exclusive. In other words, you can't have O and type B blood. You either have one or the other, and we'll talk about that a little bit later. And then that will give me 0.49 plus 0.20, which is going to be 0.69. Okay, so let's do a little bit more with two-way tables here. So I'm going to start by reviewing Venn diagrams. So let me kind of draw a little line here. It gives us a little bit more space. So Venn diagrams are very helpful in interpreting probability. So I want to make sure you remember that if you have a union, will be probability of A or B, and that means all of this intersection is shaded. And then I also have an intersection. And when I say intersection, I mean all of this area will be shaded. So intersection is a probability of A and B occurring. And it's just this shared region right there. So the probability of A and B occurring. All right, so just want to make sure you remember Venn diagrams because I'll be using those. So what is the general addition rule? Well, it's simply that probability of A or B will equal the probability of A plus the probability of B minus their intersection. So if they occur simultaneously, you would have to subtract out that overlap. So think of this as subtracting the overlap. So subtract overlap. And I just want to make sure you understand that if you have a Venn diagram and you have, let me draw this in a little bit different color here. If you have this area right here already broken out like we did in class yesterday, if you have that broken out, then you can just add up the three different values that you get, whether the numbers or whether they're probabilities. You don't have to subtract anything out. So just making that clear. Now, is this on the formula sheet? Yes, it is. Okay. What if the events are mutually exclusive? If the events are mutually exclusive, kind of think through the example we did yesterday, or it's actually today. What will happen is I have observations in event A I have observations in event B, let's just say 15, but I don't have any in common. So if the events are mutually exclusive, the probability of A and B occurring will always be 0. There'll be no shared elements. Okay, now, so let me kind of go down to the next little section. So the formula here works for mutually exclusive or not, because if two events, mark out this word here, are mutually exclusive, then the probability of their intersection is 0. So we've discussed that a couple times now. Okay, we have a situation here, a little scenario. We're going to do both a two-way table and a Venn diagram and talk about the sample space. So read the problem there and see if you could set it up yourself. What is the relationship between educational achievement and home ownership? So a random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample is identified as a high school graduate or not, and as a homeowner or not. So let's go ahead and call high school grad event A, and then not high school grad we'll call A complement, because if you add them together, you're going to account for every member of the 500 in the sample. Homeowner, let's call this event B, and not homeowner will be the complement of that. Overall, 340 were homeowners. So what I'm going to do is I'm going to put 340 here. Now I may have to change that. I won't have to change, but I'm going to have to figure out these values here. 310 were high school graduates. So 310 is here. And 221 were both homeowners and high school grads. So that number will go to 21 right here. Now, all we have to do is subtract 221 from 340, and that gives us 119. And then I can figure out this value here, because 500 minus 340 will be 160. And then I can also figure out this value is 89. And then finally, I would basically subtract 89 from 160, and I would get 71. And when I add these together, I get 190. Now I want to show you what these cells hold. These are what are called marginal distributions or marginal cell counts. Marginal. And so are these down here. So these are basically your row or your column totals. So these are marginal. It's what's in the margins. This is your table total. And then all the other four, I'll kind of highlight them. All of these four are what are called joint cell counts. And it's because everyone in each of the cells actually meets two criteria. So for example, 119 is the number of the 500 that were homeowners who did not have a high school degree. So these are going to be referred to as your joint cell counts. Joint meaning they meet two criteria. Okay, so I'm going to now put everything into the Venn diagram, and I've already said that I have A as high school grads and B is your homeowners. So just using my information, I have 89 who are high school graduates that are not homeowners, and then I have 221 that are both, so it's this cell count right here, and then B is going to be 119. So these are the homeowners who are not high school grads. So it's these guys right here. And then the 71 right here I have to put outside in the universal set. So it's those of the 500 that are not high school grads and are not homeowners. Now we have four outcomes. I want to talk about what those four outcomes are. We have high school grads and homeowners. Okay, and the number of those, so this is the number of A and B, and that's going to be 221. Another outcome is high school grad, but no homeowner. High school grad. So So not home. So the number there, and I'm going to call this A and B complement, and that's going to be 89. And then the third outcome is going to be not high school grad, but a homeowner. So this is going to be the number of A complement and B. And that's going to be 119. And finally, we have not high school grad and not a homeowner. So that's going to be A complement and B complement. And that is going to be 71. Okay, so suppose we choose a member of the sample at random, find the probability the member is a high school graduate. So this is when I'm going to look at a marginal count of 310 divided by the table total of 500, and that's going to give me roughly 62 or 0.62. B says, is a high school graduate or owns a home. So the probability, high school grad is event A, or owns a home, which is event B. So it's going to be probability of A or B. And this is the formula we just learned. So we need the probability of A plus the probability of B minus the probability of A and B occurring. So the probability of A is going to be 310 out of 500. The probability of B is going to be 340 out of 500. And then I have to subtract out the overlap. So it's going to be these this way and this way. I mean, this is where my overlap is, the 221. And that probability is going to give me 429 out of 500, and that's going to be roughly 0.858. And then finally, C says, is a high school grad and owns a home. And this one's easy because you can just go to high school grad and owns a home. It's just going to be this 221 here. So 221 out of 500 is approximately 0.442. So be very careful as to when you need to look at the marginal cell count versus a joint cell count in doing these probabilities. All right. There's another problem on the next page, and you'll notice that this problem doesn't give us counts, it gives us probabilities, and it's the same exact process, even though that's the case. I'm going to say that owning a land or having a landline is going to be event B, and not is a complement. I said that backwards. Having a landline is event A, not having a landline is a complement, so this will be B, and this will be B complement. So make sure you know A is a landline and B is going to be a cell phone. Now I want you to pause the video and fill in the table based on this information. So you're basically doing part A here, and then check back in. Okay, so I'm just going to fill this in for you pretty quickly here. And then this is a total column or marginal counts there. So here I get 0.80, 0.20, and I should get 1. Here I get 0.22, and here I get 0.78. Now I want you to notice that this may not always be exactly 1 due to round-off error. Now, what you're going to do is you're going to finish the questions, you're going to finish these, and we're going to check those together tomorrow. But finish this little thing here. May not be exactly 1 due to something called round-off error. And round-off error does not mean you did anything wrong. It just means that when you round each of the individual counts, probabilities, that when you add them all back together, it may not equal exactly 1. Okay, so again, you're going to do these 3 problems. Just take a few minutes for that, and we'll check back in tomorrow.